Somewhere in the near future, most major cities will exist twice, once in concrete and glass, and once as a living data model updated second by second from the sky and a million sensors. Urban planners call the static version of this a digital twin. It's a virtual replica that pulls data from sensors, building models, and maps into a single environment to mirror the physical city. These models help cities prepare for disasters by simulating how a new water main shifts pressure or mapping exactly where the water will flow during a severe flood. Planners can harden infrastructure before the storm hits. But a twin fed only by fixed sensors and periodic satellite passes remains coarse. It understands the city's plumbing and its roads, but it is effectively blind to the actual second-by-second motion of the people living in it. Because these current models are just snapshots, a vacuum exists for a new layer, one that allows the twin to actually watch the city move in real time. This shows the first layer, wide area motion imagery, watching a city at once, tracking every moving vehicle and pedestrian. To fill blind spots from clouds or nightfall, operators add synthetic aperture radar. Sweeping radar waves see through weather, ensuring tracking continues uninterrupted. The system archives every frame. This transforms the twin into a time-scrubbable record of the city's life, where any movement can be rewound to its origin point. But a gigapixel city feed plus a city's entire data exhaust is unreadable to humans. You could record everything and understand almost none of it. The intelligence required to close that gap lives in the newest frontier AI models. These systems process the fire hose by recognizing patterns of behavior over time, rather than just detecting pixels. This shifts the user interface from watching screens to interrogating the city. An operator types a query: "Show me every vehicle that visited these 3 addresses this month," and the model retrieves the answer. By combining persistent sensors, a full archive, and AI comprehension, we have built a machine that can remember and answer for everything a city does. When pointed at emergency response, the utility of this view is undeniable. Dispatchers route ambulances around live snarls, and commanders coordinate response from a single, shared view of the glowing logistical systems below. By replacing siloed feeds with one synchronized picture, responders have reported cutting emergency arrival times and saving tens of millions in infrastructure planning. But there is no technical seam between the model that routes an ambulance and the one that tracks a population. A rewindable, queryable twin enables retroactive, persistent tracking of every person in the city. An AI can follow any individual across days, link their movements into a pattern of life, and infer their associations, all without a warrant or suspicion. This is not speculative. In 2016, the Baltimore Police Department secretly flew a wide-area surveillance program over the city. A federal appeals court later ruled that this kind of blanket, retroactive tracking violated the Fourth Amendment. The same system that identifies a post-hurricane gas leak can, with a different query, be used to map the associations of every citizen in a public square. This is the defining property of the living twin: dual use. The model doesn't change when shifting from public safety to social control. The sensors, AI, and archive are identical. The only difference is the text prompt and operator types. The momentum behind this technology is likely too high to stop. City twins are operational today in places like Singapore and Helsinki, driven by the massive gains in planning efficiency and safety. Since the technology is diffusing regardless, the question that decides our future is, who gets to look, with what authority, and who watches them? Protecting a democratic society requires hard rules built into the system. Strict data retention limits, warrant requirements for personal tracking, and immutable audit logs that name every operator who makes a query. But those rules are only enforceable if the city actually owns its sensors and its software. If a government rents its twin's AI brain from a foreign lab, or stores the archive on infrastructure it doesn't control, it makes its most sensitive data hostage to someone else's policy. Without sovereign, on-premise control, accountability becomes impossible. The God's eye view is no longer a myth. It sits on servers. We are building the city that remembers everything. Whether that becomes a safeguard for our lives or the end of our privacy depends entirely on the legal guardrails we write before the defaults harden into permanence.